All right, let's meet the hero of the quantum world, this tiny but seriously mighty component that makes quantum computers even possible. We're going to dive in and figure out what a qubit really is.
I mean, that sounds like a riddle, right? But this very question is actually the key to unlocking a whole new era of computation. And to answer it, well, we need to meet the star of our show, the qubit.
Okay, so here it is, the qubit. That's short for quantum bit, and it is the absolute fundamental building block of a quantum computer. And getting your head around this is the first step into a truly mind-bending new reality. But, to really appreciate what makes our quantum hero so special, we've got to take a quick look back at its ancestor, the humble bit that powers every single computer, phone, and tablet you've ever used.
These bits are just beautifully simple. Think of a light switch on your wall. It can be off, that's a 0, or it can be on, that's a 1. There are no other options. It's a world of black and white, nice and simple.
And this is where everything changes. A classic bit, it's that light switch, definitely on or off, a 1 or a 0. But a qubit? Well, a qubit is more like a spinning coin. Before it lands, it's not really heads or tails, is it? It's kind of a blurry mix of both possibilities at once. This incredible ability to be both 1 and 0 at the same time is what we call superposition.
So, superposition, it's a superpower. But what does that actually let a qubit do? Well, this is a total game changer for how computers process information. Let's really dig into this. Superposition, that's the official name for this quantum trick. And think about it, a classic bit can only hold one single piece of information at a time. But a qubit, it can hold multiple possibilities all at once. That's a massive exponential leap in power. This is the perfect way to visualize it. That spinning coin. It hasn't committed yet. It exists in the state of pure potential. A qubit does the same thing, just dancing between 0 and 1, exploring all these different paths at once. So what are these qubits actually made of? Well, you can't just find one in your pocket. We're talking about the fundamental building blocks of the universe, individual atoms, electrons, even particles of light, and controlling them is a massive engineering challenge. Scientists use powerful lasers and magnets in environments that are literally colder than deep space, all just to keep these tiny powerhouses stable enough to work their magic. But superposition is just the beginning. Qubits have another superpower, one that's even more mind-bending. When they team up, something truly magical happens. This second superpower is called entanglement. Imagine two qubits linked by some kind of invisible thread. Now, no matter how far apart they are, across a room or across the galaxy, they act as a single connected system. What happens to one instantly affects the other. It's a connection that defies our everyday understanding of space and time. This just shows how bizarre entanglement really is. You can link two qubits, separate them by miles or even light years, but the moment you observe one and it snaps into a definite state, let's say it becomes a 1, its partner, no matter how far away, instantly becomes a 0. Einstein himself famously called this spooky action at a distance, and it's pretty easy to see why.
So we have superposition and we have entanglement. They're fascinating concepts for sure. But why do they matter? Why build these incredibly complex machines just to harness these spooky effects?
Because when you combine these two phenomena, you get a new kind of computing power. It's like having a team of explorers searching a vast landscape. Instead of one explorer checking each spot one by one, you have millions of them searching every possible spot, all at the same time. A classical computer has to trudge through problems one step at a time. A quantum computer, though, can test millions of combinations simultaneously. This has the potential to turn problems that are currently impossible, like designing new medicines or discovering new materials, into solvable challenges.
This chart really puts it into perspective. We're not talking about a small upgrade here, like a slightly faster laptop. This is an exponential leap in processing power. For some of the world's most complex problems, this changes everything.
But the qubit isn't just about building faster computers. Its very existence forces us to rethink our entire understanding of reality. It's like a window into the strange and beautiful world of quantum mechanics.
This is the profound takeaway. A qubit is Nietzsche's way of showing us that, at the smallest scales, the universe doesn't operate on certainties, but on a rich tapestry of probabilities. It's a world of pure potential, where things aren't fixed until we actually look.
Understanding this one single concept, the qubit, is the key. It unlocks the door to an entirely new way of thinking, not just about computers, but about the very fabric of our world.
And we're just scratching the surface. Next time, we'll explore how these amazing qubits are actually put to work using quantum gates. I hope you'll join me for that. Until then, stay curious.